Hello everybody, my name is Anna Andrade and today I'm going to be talking about Chapter 11, Developing Whole Number Place Value Concepts. Alright, let's get started. At the end of this chapter, intellectuals will know how to learn what is basic facts, the importance of place value concept, pre-place value understanding, integrating base 10 groupings with counting by ones, the symbolic scheme that we use for writing numbers, guiding questions, physical models for base 10 concepts. Let's begin. What is basic facts? Well, basic facts is understanding pre-placed values. According to the text, a significant part of this development includes students putting numbers together, composing and taking them apart, decomposing in a wide variety of ways as they solve addition and subtraction problems with 2- and 3-digit numbers. So why is this important to learn place value concepts? Well, it is important for children to learn place value. It is a way for students to think about large quantities and to enhance their ability to invent their own computation strategies. If children do not learn whole numbers and basic place value concepts, adding, subtracting, and rounding, then children will be facing chronic low levels of mathematic performances. Now, how I saw this and what I see at work is true. The more students, it's like a domino effect. So what I've noticed is that if students do not understand this concept, then the higher the grade level they go, the harder they will struggle. They will struggle. And so they have to start all over again from the very beginning. So it's very important to have an intervention if the students are not meeting those needs, if they are not up to date, if they are not able to be able to count or learn their place values. It's very important. So how I see this is like a domino effect. So in first grade, students count and are exposed to patterns and numbers up to 120, and they learn to think about groups of 10 objects as a unit. So right here we have typically what we would see a counting sheet from 1 to 120. So they will start from 1 and they will count all the way to 120, or typically what they would have is they would have the students write the numbers or cross out the boxes or color in the boxes, whatever it takes to get their attention and focus. In second grade, these initial ideas of patterns and groups of tens are formally connected to 3-digit numbers. So we have right here the boxes. So right here is where we begin demonstrating the units. So the numbers, so the tens and the ones, and how the ones become the tens, and when we have 10 tens, they become 100, and so forth and so on. In fourth grade, students extend their understanding to numbers up to 1,000 1 million in a variety of contexts. In fourth and fifth grade, the ideas of whole numbers are extended to decimals. So now, after they learn how to count from 1 to 120, students will learn how to regroup. From here, they will learn that now we have not just ones and tens and hundreds, but now we are adding tenths, hundredths, thousandths, and 10,000ths. The is where it really starts getting a little tricky, especially for students that haven't grasped the concept of where to place their numbers and what place value. All right. So understanding pre-placed values. So from the very beginning. So once the students already understand how the concept of 1 to 120 is, now we start talking about pre-placed values. So right here, I would ask you guys, and pause for 5 seconds and just answer these questions. So question number 1, how many ones are required to make a 10? How many groups of 10 do you see? How many groups of 1 do you see? basic questions, right? So we're going to identify the pre-base 10 understanding based on a count by ones approach to quantity. Teachers should have a formative assessment to see what the students know about pre-placed value. Children at a young age only know count by ones approach from preschool to second grade, right? So at this time, preschoolers, kindergartners are still in the one-to-one correspondence, and we're trying to now stretch that and extend it to learning the pre-base 10, which is what they typically learn. They start teaching them in kindergarten and demonstrating them to them how the ones become the tens, and then in first and second grade they start making those connections even more and more clear of how the eights become the ones become the tens. How do we regroup that the 8 is not just 8 ones and the 1 is not 1 1. So for example, the number 18 to a child means 18 ones in altogether, and they are unable to identify the place value group for the number 18. So we would be teaching them that the 8 is its own separate number. We have 8 ones, and the 1 becomes a 10. So it's a group of 10. So the groups of 10 to represent the quantities. Integrating base 10 groupings with counting by ones. The objective is to help students understand the concept of integration by knowing how to group by tens. Your foremost objective should be helping students integrate the grouping by tens concept with what they already know about numbers from counting by ones. Groupings with fewer than the maximum numbers of tens are referred to as equivalent groupings. Understanding the equivalence of the base 10 grouping and the equivalent grouping indicates that grouping by tens is not just a rule that is followed, but also that any grouping by tens, including all or some of the singles, can help tell how many. Many computational techniques, such as regrouping and addition and subtraction, are based on equivalent representations of numbers. So right here we have the grouping stages. The first one is the green one, which is we will see the visual representation. The grouping stage would be unitary count by ones. So we would do the counting approach, 1, 2, 3, so on and so forth. And here is where students should be able to tell how many by counting each piece. Are you not yet able to think of 10 as a single unit? Use counting by ones as the only way they are convinced that different sets have the same amount. The next group is base 10 count by grouping of tens and ones. So the visual representation now is we got all of these ones and we start grouping them by tens. So one ones represents 110. Another group of 1 ones represents another 10. So now we have 1, 2 tens, 3, 4, 5 tens with a remainder of 3 ones. Equivalent non-standard base 10. So now before counting, students will trade and then count by 10, 20, 30. So now that's when we start grouping the pieces flexibly into versions that include tens and ones, but all trades have not been carried out. Use these alternative groupings to relate to computation by being able to trading or regroup numbers in a variety of ways. The symbolic scheme that we use for writing numbers. So right here, we're going to talk about language, how it plays a key role in making connections between creating not just one-to-one correspondence, but now how the 3 is known as ones and the 5 is becoming a 10. So the explicit count by groups and single matches the individual digit as the numbers written in the usual left to right manner. So how we see up here, we have the left to right manner. So we have our ones place starting on the right, and then we have the left, which is our tens, and how the 3 is an individual and the 5 are groups. The symbolic scheme that we use for writing numbers, ones on the right and tens on the left of ones, and so on, must be coordinated with the grouping scheme. But keep in mind that having students see the 10 as both 10 ones and the 1 10 may be a challenge. So when we start using the language of how many ones do we need to make 110, that 110 can become very tricky because we are still using the word 1, even though 110 represents 10 small cubes in one group. In the grade section, we need to note that all 3 methods of counting are coordinates as the principal method of integrating the base 10 concept. So then writing the names and the oral names as well. So now right here we have the base 10 concepts and the standard and equivalent groupings meaningfully used to represent quantities. So right here we have three tens and 2 ones, and what happened is we used to have 2 ones, and we used to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We used to have 12 ones, and what we did is we regrouped a set of 1 ones to make 110, one whole 10, and how that would be seen as written form would be 32, and as an oral name would be standard 32 and base 10, 3 tens, and 2 ones. So what we're doing is we are showing it visually, and then we are writing it, and then we are saying it and reading it. So these are just some guiding questions. You can not just tell students that these counts will all be the same and hope that will make sense to them. It is a relationship they must construct themselves. And in order to do that, we need to ask them questions that will help them to guide. It's a guiding. So I made this little cheat sheet, whole numbers, place value, and guiding questions. And these are some guiding questions that I got from the text, and they're very useful. What will happen if we count these by groups and singles? How can we be really certain that there are a certain amount of numbers in here? How many do you think we will get if we count by ones? How many ones do you see, and how many tens do you see? Physical models for base 10 concepts. Here's where we start with the fun process of what we are learning and mastering basic facts and also understanding pre-placed values. I'm super excited. So physical models for base 10 concepts play a key role in helping students develop the idea of a 10 as both a single entity and as a set of 10 units. Remember though, that the models do not show the concepts to the students. The students must mentally construct the 10 makes one relationship, so 10 makes the 1, and so we need to impose it on the model. These practices will be shown in the activities that I will be providing below. Here we have 2 group models that reflect the relationship of ones, tens, and hundreds. So let's look at the first model, Model A, groupable base 10 models. When students put 10 beans in a cup, the cup of beans literally is the same as the 10 single beans. So this is where we begin to regroup. So we can have 2 cups, and then students can physically start placing each 10 beans in one cup and 10 beans in the next cup, only 10. And the remainder should not be inside the cup, so they can see what the ones look like, the independent ones, and how we establish a relationship with the group of 1 of 110. So like I mentioned, plastic containers help to make the connection between the